so looking at what we did yesterday, or sorry, on Wednesday we had our test, so on Tuesday. So we looked at a few definitions, and I told you that these were homework, but just in case people didn't get them down, and I think outcome was kind of a different one, but important definitions when we're looking at experimental probability. So all we did in class on Tuesday, was do some experiments to explain all of this stuff. Experimental probability. So the probability is the likelihood an event will happen. A trial is one round of a probability experiment. So if I was like flipping over a card or flipping a coin, it would be one time flipping that coin would be one probability experiment. Okay, an outcome is a possible result from that experiment. So if we're talking about flipping a coin again, the possible results, an outcome could be heads or an outcome could be tails. Now an event is a set of outcomes with the same result. Okay, so if we have a whole bunch of heads in a row, we have an event. Okay, so we've got the same results. Experimental probability. So this is determined using the results from an experiment. So that's kind of what we were talking about on Tuesday. We looked at experiments that we made in class and made a probability. You'll remember the one that I did with the cards on the simulator. When I did 100 simulations, we ended up having exactly what we thought the probability would be almost, but it was a little bit off. Now experimental probability, the way we determine it, and remember I said it's always a decimal, is the number of successful trials, and that's important, divided by the total number of trials. Okay, so if I was flipping a coin, the way I would determine that, like if I said, what's the experimental probability of flipping heads if I do this 15 times? The number of successful trials would be how many times I flipped a heads, and the total number of trials would be 15. So let's say I flipped it 5 out of 15. The experimental probability would then be 5 divided by 15. I had 5 times that I flipped heads, and I had 15 total trials. And I always want to put it into a decimal, but you can write it as a fraction. It just needs to be reduced. And then when we look at a decimal, if I want to change that, I can make that a percent by multiplying it by 100. Okay, so you should be fairly comfortable going between those. On Tuesday, we also talked about that gone fishing experiment. Now, what this has was, let's say we did 30 trials. So this is kind of...
them to the main office. I caught them to the main office.
And there's an announcement. But this is kind of just a pretend thing where I gave you some results. So we have 30 trials. And each of them, it's always 30. And then I said I got 9 carp, 15 bass, and 6 catfish. Now the way I can find this, we always have a fraction we always want to reduce. So I'm going to divide both of these terms by 9. So I would get 3 over 10. Here, I would get, both of them can divide by 15, I would get 1 over 2. Here, both of them can divide by 6, I'm going to get 1 over 5. So this one equals 0.3, or 30%. This one equals 0.5, or 50%. I'm saying this one like you can see me standing up here writing this. I know you can't. This is 0.2 or 20%. And now when I add all of those up, it equals 100%, or the decimal equals 1, or the fraction would equal 1 as well. Okay, we should always reduce though when we're doing this. The other way we can look at things like this is if I wanted to look at a question and I said, what's the probability that we don't have carp? Well, I could look at what are the total numbers of carp and kind of go through it. So I've got my probability of getting carp. Well, I know that it has to add up to 100%. So we've got 100% is 1 minus 0.3, which is 100% minus 30. So the probability is 70%. The other way I could do it is add the other two together because we know that 0.5 plus 0.2 is not carp, that's catfish and bass. That's 0.7, which is 70%. Okay, so that's another thing when we're looking at what not. Okay, and I'm kind of rushing through this. You can go on our website and look at it, or you can ask whoever's in for me to replay it for you if you need to, or stop when we're doing this. But this is the general part of this note. Okay, and going back, going through this. What you have to realize, so we've got a whole bunch of examples here of rolling dice. The big thing, and these are all the exact same. Okay, what we need to recognize is that our total is going to be the addition of all of this. So our total number of events that we've done is 1 plus 2, which is 3, plus 5, which is 8, plus 3, which is 11, plus 4, which is 15, plus 3, which is 18. So our total is always 18. Now the probability of rolling a 7, what you have to recognize is there's no 7 here. So that's going to be 0. That one's the easiest one to do. The probability of rolling a 6. We're always going to make these over 18, and I'm always going to reduce the fraction, and I won't make it a decimal, and I'm not going to make it a percent. You guys can do that yourselves, because it says up here, make it a decimal, make it a percent. But the probability of rolling a 6 is just 1, because I look at my chart, I've got a 1, divided by the total number. Now to turn that into a decimal, all I have to do is 1 divided by 18. To turn that number into a percent, I multiply it by 100. The probability of not rolling a 6. Well, the probability of not rolling a 6 is just the probability of rolling a 6 taken away from 1. So that's going to be 17 out of 18. There was 18 in total. We only had 1 up here, so then there had to be 17 other events. Now the probability of rolling an even number. Now we've got to do some addition. We've got to look at all of our even numbers. It's going to be 4 plus 5 plus 1. So we got 4 plus 5 plus 1 over 18. And we can always reduce that. That's going to be 10 over 18. We can divide that by 2. We get 5 over 9. All right? Now there's a big difference between and or, and you really have to pay attention to it. And means both of them. Okay? They both have to happen. Or means either one. So if I have the probability of rolling an even number or a number greater than 3, that's going to be all of my even numbers and the numbers that are greater than 3. Okay? So that's also greater than 3. The weird thing is that I use and in that case. So we now have 10 plus 2, which is 12 over 18, and that equals 2 over 3. Now when I look at the next one, they have to be even, but they also have to be greater than 3. So there's only 2 numbers that are even and also greater than 3. So we get 6 out of 18 here, which was 1 plus 5, and that's 1 over 3. Again, you can make those into a decimal. All right? Your homework is there. So page 66, numbers 1 to 4, 6, 7, 9, and 10.